3.4 is piecewise defined functions. Sometimes a function is defined in pieces for different intervals of the domain. So with given conditions, you would use a different piece of the function. This is pretty common in things like wages, or in example 1, postage. The postage paid for a first-class letter jumps by 21 cents for each ounce after the first ounce, but does not increase until the weight increases by 1 ounce. The table gives the postage for letters up to 3.5 ounces. Write a piecewise defined function that models the price of postage and graph the function. The way these functions are written is that we write f of x equals, and then we have a curly brace that contains each of the pieces of the function. After each piece, we'll have the conditions. So the postage is going to be 49 cents, okay, 49 cents if x is less than or equal to 1 ounce but greater than 0 ounces. It'll be 70 cents if x is 2 ounces or less but greater than 1 ounce. Here you notice that if someone comes in with a 1 ounce letter, they are going to be paying 49 cents because the 1 is included with the equals here in this condition. So we use this piece. While this condition says x is strictly greater than 1, so you would not charge that person 70 cents for a 1 ounce package. It would be 49 cents for every 1 ounce package. Continuing, we have 91 cents if 2 is less than x, which is less than or equal to 3. 112 cents, or $1.12, if 3 is less than x is less than or equal to 3.5. You can, of course, graph this by hand using the boundaries given. I'll go ahead and show you how to do this on the calculator. Our first function part has to be written as its own function. So our first function in the calculator is 49, y equals 49. And the way we write our condition is to put a slash there and then open up parentheses to say what your condition is going to be. Those conditions are in the test menu here. So second, math, and there we have our different conditions. Okay, so we're going to first say, going back to the function, that x is, go to the test, greater than 0, and back to the test, back to the test menu, go to logic, we're going to put and. Okay, x is less than or equal to 1, so less than or equal to 1. Close that condition. And if I want to see this graphed in my window, let's say we set our window to be a minimum of 0, and we're going to go up to 3.5, so let's go to 4 as a max on the window. And on the y, we're going to be coming from 49 cents, so let's just say a minimum of 40 and a maximum of 112 cents, so let's say 120, just so we see in the window everything we want to see, and we'll graph that. So what it does is it graphs only that flat constant line from between 0 and 1. We can work on our second piece. We have to write it as a second function, so 70, and put our slash parentheses, and we're going to say x greater than 1. And back into the test, we put that logical operator of an AND. So we have to be greater than 1, and x must be less than or equal to 2. And close what those conditions are. Now when you graph again, you'll see the second piece being graphed. The third piece we just have to put as a third function. It'll be 91. Put our slash and put our conditions in parentheses. X being greater than 2, and the logical operator of AND, x less than or equal to 3. Okay, graph that, and you see the third piece, and then our fourth piece we put in as our fourth function, 112 cents, and put our slash parentheses so we can start our conditions. So x is test greater than 3, test, put in our logical operator of AND, x is less than or equal to 3.5, and close the conditions. And let's see what the graph looks like there. Let me see. So you can see in the table you'll have different values here of for each of your outputs. We're not getting a whole lot from the table because we're moving our x's by units. So in the table we could start with 0 and then let's say maybe change that table by tenths instead. And then when you look at the table you get a lot more useful information there. So up to 1 ounce it's 49 cents. Once you hit over 1 ounce it's 70 cents. Once you hit over 2 ounces it's 91 cents, and once you hit over your 3.1 it's 112 cents. In example 2, we're working with residential power costs. Excluding fuel adjustment costs and taxes, the rate Georgia Power Company charges its residential power customers for electricity during the months of October through May is given in the table. We have the monthly kilowatt hours in the first column, 0 to 650. You have a monthly charge of $7.50 plus $0.045991 per kilowatt hour. Right? More than 650, so apparently this column or this row is 0 up to and including 650. This row starts off with more than 650 and up to 1,000. You can look at the next row, it says more than 1,000. So this would be up to and including 1,000. Would be $37.40 flat rate plus 0.03946 per kilowatt hour above your 650. More than 1,000 would be $51.21 flat rate plus 0.038737 per kilowatt hour above the 1,000 kilowatt hours. So we want to write a piecewise defined function that gives the monthly charge for residential electricity with the x input equal to the monthly number of kilowatt hours. All right, so they've already named the function c for us. So that's c of x equals and make a curly brace. It's going to be big enough to hold our 3 pieces. The first piece is $7.50 plus 0.045991 times however many kilowatt hours you use. Okay, and that's if X is less than or equal to 650 and greater than equal to 0. Yes, we want the equal to there. If you have electrical service, it doesn't matter if you don't use it, you will still be charged. So even if you're using 0 kilowatt hours, put 0 in for that X. You don't get charged that extra amount, but you do get charged $7.50 just for being able to have the option of turning on a light switch and it works instantly. All right, the next tier would be $37.40 plus 0.03946 per kilowatt hour above 650. So if they are using 500 kilowatt hours, we're not multiplying this by 500 and then adding the 3740 because 500 is not above 650. We would be in this tier. So let's say that we used 651 kilowatt hours. What would the charge be? It'd be $37.40 plus 0.03946 times 1. Okay, if you used 652 kilowatt hours, it'd be $37.40 plus 0.03946 times 2. Okay, so the pattern is that this is changing based on how much this changes. So how much is this over 650? So it'd be the number of hours if it was 651, and then subtract the 650. That gives you just 1 hour to be charged this variable rate, and then add the flat rate. If we had 652 kilowatt hours, then you would subtract the 650. That would give you 2, and you'd be using 2 times that variable rate plus your flat charge. All right, and then the next tier is $51.21 plus 0.038737 times, and this is the number of kilowatts above 1,000. So it'd be X minus 1,000. All right, let's get our conditions written in there. So the conditions for the second tier is if 650 is less than X, which is less than or equal to 1,000. We don't want to put the equal to on the 650 right here, because 650 kilowatt hours is included here. We don't want to include it in both places and have 2 different charges on figuring that. Okay, so the third tier is if X is more than 1,000. So we want to here find C of 950 and explain what it means. So C of 950, well, the X is 950. That's going to fit in our second condition. So we'll use the second piece. So we have 37.4 plus 0.03946 times 950 minus 650 is 300. So you're getting charged for the 300 hours that's over the 650. And that's 49.238. Of course, practically, And what it means is that if 950 kilowatt hours are used, then the charge will be $49.24. Make sure that you're rounding to the nearest whole cent. We don't want to have 8/10 of 1 cent. Find the charge for using 1560 kilowatt hours in a month. Okay, so this kilowatt hours, 1560, that's going to be sitting in that third condition. It's 560 kilowatt hours over the 1000. So charge for using 1560. So charge for using 1560 kilowatt hours. It's going to be 5121 plus 0.038737 times the 560 kilowatt hours that is above the 1000. Put that into the calculator. 51.21 plus 0.038737 times 560, and that gives us 72.90272. The charge, again, you want to round to the nearest whole cent, $72.90. All right. We want to use a graph of the function to determine how many kilowatt hours would be used if the monthly charge is $122.87. So we can do that. Let's go ahead and clear out our functions that we had before. We can put this in 7.5 plus 0.045991x, and then our condition we put again in two pieces. So x is greater than equal to 0, and then our logical operator of and, meaning both of these conditions have to be satisfied at the same time. X is less than equal to 650. And close that condition. If you want to start seeing the graph, we can set our window 0 to, let's say, 0 to 1500, just so we're sure to see, a lot of these other numbers that are going on over here. So we'll do a zoom fit. We'll have to do a zoom fit every time we graph when we're doing this. So zoom fit, there we go. That's that one piece. And let's put in our second piece. So our second piece is 37.4 plus 0.03946 with an x minus 650, and we put our slash to start our conditions, and that's x being greater than 650, our logical operator of and, x is less than or equal to 1000, and I'm seeing I did not, my parenthesis didn't get stuck in there, so I'm going to insert that here. Here we go. And let's see what that looks like. We'll do another zoom fit. There you go. You can see the graph is slightly a smaller slope. Okay, and here we go. We've got 51.21 plus 0.0383737 times x minus 1,000. Okay, and our slash to show we're going to start conditions here. X strictly greater than 1,000. Okay, and let's see, we'll do another zoom fit so you can see all that going. See that your rate is going down for each of these tiers. You have that base charge going on as well. So using that graph to determine how many kilowatt hours will be used if the monthly charge is $122.87, well, that would be a C of X. If you choose, you could put that into a fourth function, 122.87, and see what we get here. Graph, you don't even see it. So if we go to the window, you could see the Y max is 70. Not good. So it's not even going to get up to that charge of 122.87 with the window we have. Let's say that we go to 3,000 on our X max and do another zoom fit to see if we can, yeah, there we go. We've got an intersection there. So we can now intersect if you like. We don't want to intersect Y1. That's not the piece that we are actually intersecting with that horizontal line. Y4, yeah, that's our horizontal line, and scroll up until it says Y3. Yes, that's the other function we want to get. So we have looks like 2,850 kilowatt hours. Okay, so 2,850 on your kilowatt hours there. Example 3 is exploring wind chill factor. Wind chill factors are used to measure the effect of the combination of temperature and wind speed on human comfort by providing equivalent air temperatures with no wind blowing. One formula that gives the wind chill factor for a 30-degree Fahrenheit temperature and a wind with velocity v in miles per hour is this piecewise function. There we go. So the wind chill factor, and all of these are for a 30-degree temperature. Wind chill factor when it's 30 degrees out will feel like 30 if the wind velocity is between 0 and 4. If it's the wind is between 4 and 55.9 miles per hour, then we use that second piece of the function. Put this into the formula. And then if it's the third piece, it'd be the wind being a velocity more than 55.9, and it's just basically flat out cold. It's going to feel like negative 6.5 degrees when the wind velocity is that high. So let's find the wind chill factor for the 30-degree Fahrenheit temperature if the wind is 40 miles per hour. If we're talking 40 miles per hour wind velocity, that fits between 4 and 55.9 miles per hour. So we're going to use the second part of the piecewise function to figure that. 1.259 times our wind velocity of 40 minus 18.611 times the square root of your 40. Arrow right to get out of that square root. So I have a 62.255 there, and enter, and it's at that point it's going to feel like a negative 5.1 degrees. The wind chill factor for 30 degree temperature if the wind is 65. So if it is 65, it's that's going to be bigger than 55.9. So it's just this constant function of negative 6.5. It just feels just cold, negative 6.5 degrees. For the next part, we want to graph the function for wind velocity between 0 and 70. So one thing that we can do is go ahead and set our window from 0 to 70, and then we'll clear out our old functions and put this function in of 30 slash parentheses x being greater than or equal to 0, logical operator of and, x less than 4. Okay, close that condition and go ahead and do the next piece. 1.259x minus 18.611 times the square root of x plus 62.255 and our conditions, we'll put our slash parentheses and we'll say x is greater than or equal to 4. Our logical operator of and, x is less than equal to 55.9. Close the conditions. And our last piece is negative 6.5 slash, open up parentheses to put your conditions, x, and our operator here is greater than, x greater than 55.9, and we'll close those conditions. Okay, we've already set our window to go from 0 to 70 on the x, so let's do a zoom fit and see that first piece, how the temperature feels like it's a lot colder until you get over a wind speed of 55.9. It's just frigid cold, negative 6.5 degrees. All right, what are the domain and range of the function graphed in part C? Well, what we graphed, this is your domain. That's what your independent variable is given in the graph. So 0 to 70 and including those. And our range is going from a negative 6.5 at the lowest to a 30 at the highest. Our last example is on service calls. The cost of weekend service calls by AirTech Services is shown by the graph. We are tasked with writing a piecewise function that shows the cost for service during the first 5 hours as defined by the graph. So we can see on the axes they've named the function c, and they're using an independent variable t. So we'll call this function c of t equals, we have 3 pieces, so just make a curly brace capable of holding all 3 of those pieces. The first piece, they're telling you that this is at 330, and that is if t is between 0 and 1. not including the 0, and it does include the 1, so we need to put an equal to with that 1. The next is showing at 550, so 550, and that is graphed between 1 and 2, not including the 1 but including the 2. You see that solid dot at the T of 2. And the next level is 770, and that's for T being between 2 and 5, not including the 2 but including the 5, and that is our piecewise function for that problem. That's it. Go ahead and give the homework a try and let me know if you have questions.